Modern civilization runs on something most people never see: tiny pieces of silicon, semiconductor chips. They power smartphones, laptops, cars, satellites, artificial intelligence systems, and nearly every advanced technology device used today. Without semiconductor chips, the modern world simply stops working. But producing these chips is one of the most complex manufacturing processes ever created. And at the center of this global technological infrastructure stands a single company, TSMC, the Taiwan Semiconductor Manufacturing Company. Today, TSMC manufactures the majority of the world's most advanced semiconductor chips. Companies like Apple, Nvidia, AMD, and Qualcomm all rely on TSMC to produce the processors that power their products. In many ways, this company has become the factory that powers the modern world. But the story of TSMC begins decades before artificial intelligence, smartphones, or cloud computing existed. To understand how one company became so important, we need to go back to the early days of the semiconductor industry. In the 1970s and 1980s, most semiconductor companies designed and manufactured their own chips. Companies like Intel built both the chip designs and the factories required to produce them. But building semiconductor fabrication plants known as fabs is extremely expensive. Each new generation of manufacturing technology requires more advanced equipment, more precision, and significantly higher costs. By the mid-1980s, it became clear that many companies could design chips, but very few could afford to manufacture them. This created an opportunity for a new type of company, a company that would focus only on manufacturing chips designed by others. In 1987, Morris Chang founded the Taiwan Semiconductor Manufacturing Company. His idea was simple but revolutionary. Instead of designing chips, TSMC would manufacture chips for other companies. This business model became known as the foundry model. Under this system, companies like Nvidia or Apple could focus on chip design, while TSMC would focus entirely on manufacturing. At the time, many people believed this model would fail. Chip companies traditionally controlled their own production. Outsourcing manufacturing seemed risky. But Morris Chang believed the future of the semiconductor industry would require extreme specialization. Design and manufacturing would become separate disciplines, and TSMC would focus on becoming the best manufacturer in the world. Over time, that strategy proved remarkably successful. As semiconductor technology advanced, manufacturing became increasingly complex. Each new generation of chips required smaller and smaller transistor sizes. Transistors are the tiny electronic switches that make up a processor. Modern chips contain billions of these microscopic components. Manufacturing them requires extraordinary precision. Inside semiconductor fabrication plants, silicon wafers pass through hundreds of highly specialized machines. Each step deposits, etches, or modifies microscopic layers of material. The entire process can take months. Even a tiny defect can ruin an entire wafer. Building a semiconductor factory capable of producing advanced chips costs tens of billions of dollars. Only a handful of companies in the world can afford to build and operate these facilities. TSMC invested heavily in developing this capability. Instead of splitting resources between design and manufacturing, the company focused exclusively on production technology. This allowed TSMC to advance faster than many competitors. Over time, the company became the preferred manufacturing partner for major technology firms. Apple relies on TSMC to manufacture the processors used in iPhones and Mac computers. Nvidia depends on TSMC to produce the GPUs that power artificial intelligence systems. AMD, Qualcomm, and many other companies use TSMC foundries to build their chips. In effect, TSMC became the central manufacturing hub for the global semiconductor industry. But manufacturing advanced chips requires more than just factories. It also requires specialized equipment. One of the most important machines used in modern semiconductor manufacturing is the extreme ultraviolet lithography system. These machines are built by a company called ASML in the Netherlands. Extreme ultraviolet lithography allows manufacturers to print incredibly small transistor patterns onto silicon wafers. These patterns are measured in nanometers. A nanometer is 1/1000th of a meter. To put that into perspective, A human hair is roughly 80,000 nanometers wide. Modern semiconductor transistors are often just a few nanometers in size. Producing structures that small requires some of the most advanced engineering ever developed. This is why only a small number of companies can manufacture leading-edge chips. TSMC is one of them. And because of this capability, the company now sits at the center of the global technology supply chain. But this concentration of manufacturing power has also created geopolitical tension. Most of TSMC's advanced manufacturing facilities are located in Taiwan. That means a large portion of the world's semiconductor production depends on a relatively small geographic area. Governments around the world recognize the strategic importance of this technology. Semiconductors power everything from smartphones to military systems. Artificial intelligence development also depends heavily on advanced chips. As a result, semiconductor manufacturing has become a major geopolitical priority. The United States, Europe, China, and other countries are investing billions of dollars to expand their domestic chip manufacturing capabilities. New semiconductor factories are being planned in multiple regions. But building a competitive semiconductor industry is extremely difficult. It requires decades of experience, massive financial investment, and access to highly specialized equipment. TSMC has spent more than 30 years developing its manufacturing expertise. That experience cannot be easily replicated. This is why many technology companies continue to rely on TSMC despite geopolitical uncertainty. In recent years, TSMC has begun building new factories outside Taiwan. The company is constructing facilities in the United States and Japan. These projects are intended to strengthen supply chain resilience and reduce geopolitical risk. But even as the semiconductor industry expands globally, TSMC remains the dominant manufacturer of advanced chips. Its factories produce some of the most sophisticated processors ever created. These processors power artificial intelligence training clusters, high-performance computing systems, and next-generation consumer devices. In many ways, the modern digital economy depends on the work performed inside TSMC's fabrication plants. Inside these facilities, silicon wafers move through enormous machines. Robotic systems transport materials between manufacturing stages. Engineers monitor production processes with extraordinary precision. Each wafer may contain hundreds of individual chips, and each chip may contain billions of transistors. The scale of modern semiconductor manufacturing is astonishing, yet the entire process operates with microscopic precision. Tiny patterns etched into silicon determine the performance of technologies used by billions of people. As artificial intelligence continues to advance, demand for powerful processors will only increase. Training the next generation of AI systems will require even more computing power. That means more advanced chips and more advanced manufacturing technology. Companies like NVIDIA and Apple will continue designing new processors to support emerging applications. But manufacturing those designs will require facilities like the ones operated by TSMC. This is why the company has become so important. TSMC does not build smartphones. It does not build graphics cards. It does not sell consumer products. Instead, it builds the tiny processes that power the companies that do. And in doing so, it has quietly become one of the most important technology companies in the world. The factory that powers modern civilization.